Welcome and hello. This is a video tutorial on HEC HMS, and in this tutorial, I'm going to be discussing simulation runs. Simulation runs are the primary method of computing results. Each simulation run requires a basin model, meteorologic model, and control specifications. In this lesson, I will also run a simulation and view results briefly at the very end, but the focus of this lesson will be on creating and managing simulation runs, as well as setting up and describing some of the settings. Let's go ahead and get started by creating a simulation run. So to do that, we'll go up to the Compute menu and Create Compute. And now I have Simulation Run here as my first option. You may not see the simulation run selectable if you don't already have a basin model set up, meteorologic model set up, and a control specification. So these are some parts of my model that I already have in place, as you can see from the Watershed Explorer. All right, so let's go ahead and do that. Compute, create compute, simulation run. And now I have a 4-step tutorial wizard to step through, starting with giving my simulation run a name. Run 1 is just the default name. And then the instructions on this dialog box here are also down at the bottom. So it says to continue, enter a name, and then click next. So we'll go ahead and do that. I do want to actually back up just a moment and say that a simulation run can also be created from the simulation run manager. So before we were in create compute simulation run, but if I go to compute simulation run manager, now I have a dialog box where I can view all my simulation runs and then make some edits after they've been created. So let's go ahead and click new. And now I have the same dialog box that we saw before. I'm going to go ahead and give this simulation run the name May 1996 and then click next. This is step 2 now. It says to select a basin model and then click next. So our one and only basin model here is named Puxatawny. So the first option is selected by default. So I'll just go with that. Click next. As before, we only have one meteorologic model. So that's called May 96 and then next. And the fourth and final step here is to select the control specification. And this is my only control specification. So I'll go ahead and select that and click finish. Now we see a simulation run listed here in the list box. So if I go ahead and select that, I have a few different options such as making a copy, renaming, deleting, or making edits. If I click make edits, I see the component editor pop up, which we'll talk about in just a moment. Let me go ahead and close that. I can also make a copy, rename, delete up in the Watershed Explorer. So for most of the lessons up to this point, we've only talked about the Components tab in the Watershed Explorer, where we define the basin and the meteorologic model and those parameters. But there's also 2 other tabs here, Compute and Results. So if I click on Compute, we now have a list of the simulation runs in this directory. So I'll go ahead and click the plus symbol to expand that. And now if I right click on this simulation run, I can create a copy, rename, delete, or when I select it, I can update the description down here in the components editor. The user's manual next describes how to import a simulation run. And to do that, we'll go up to File and then Import and then Simulation Run. Once you select a simulation run and it's imported, all the necessary simulation components, such as the basin model, meteorologic model, control specifications, and then other supporting data, will also be imported into your current project. What I mean by supporting data, that would refer to as time series data sets, grid data sets, any maps, layers, shapefiles, those sorts of things. Let's go ahead and do that. But what I'm going to do is just delete this entire project and then create a blank HMS project and then import using this file import simulation run and then bring in the data from this project. So give me just a moment here. Okay, so I just opened up HMS. I'm going to go ahead and create a project and then import that simulation run. Call it lesson 59. I'll navigate to where I want to put this project and then click create. Okay, now I'm going to go up to file and then import and then simulation run. Now I need to navigate to a project, and this is actually the one I wanted to use. Here's the .hms file, so go ahead and click that and then select. Now it asks me which simulation run I want to import, and it's this one right here. It happens to be the only simulation run in this project, so I'll click import. Now it asks me if I want to import some of the data. For instance, if I want to actually make a copy of the data itself versus making a reference to the data in its original location. So I'm a fan of making a copy in most cases. So I'm going to go ahead and click yes. And now it's asking me the same thing. If I want it to be localized or external, I'm going to say localized. So yes. And then this is the same question for the meteorologic model because it uses some time series data and gridded data. And then yes, I'm just going to keep saying yes. It looks like we successfully imported a simulation run because I have that listed right here. We can also see the list of simulation runs and actually run the simulation in the compute toolbar, which I don't have in view right now. So I'll go up to view, toolbars, and then compute, and that shows up right here. Right now, no simulation run is selected, but I can make that selection right here. Okay. And then to run the model, I'll go ahead and click this button, but not yet. We'll hold off on that for just a moment. If we select the simulation here in the Watershed Explorer, down below we have a components editor for that simulation run. And there's three tabs I need to talk about: simulation run tab, ratio tab, and states tab. The simulation run tab is the only required tab, and then ratio and states are optional features, but I'll also describe what they do. Okay, starting with the simulation run tab, we have the description of the simulation run. We have the output DSS file, and where it's putting it here is in the lessons, the project directory, and then the simulation name.dss. But you can go ahead and change this if you want. I think this is a good default name. Next down is we have the output. So this refers to the actual results that are going to be written during the simulation to the DSS file, which will be available in this results tab. Right now, it just says all, and that's the default. I can also select minimal. So if I select minimal or all, this little settings button on the far right is disabled. But if I select selected as my output, I can now click this little gear icon or the settings icon, and now I can go ahead and check checkboxes to tell HMS which data sets or which results do I want written as an output. So I can go ahead and check these on or check them off as I wish. At the top, there's a couple filters. So in the event I had a much larger hydrologic model with tons of hydrologic elements, I can go ahead and more quickly find the element that I'm looking for or filter by the time series filter. One other thing to point out here is the output interval. I can actually change the output interval to the actual interval of the control specification or multiple thereof. So 15 minutes is currently the control specification time interval. So I can set it to 30 minutes instead, or an hour, or 2 hours if I want, but I can't set it to 20 minutes, for instance. So there may be some situations where you want to see the output calculated, but not at the default output interval. Once you have all your specified results selected, go ahead and click Save and then Close. I'm going to go ahead and just change that back to all, though. Okay, next up is the basin model, meteorologic model, and control specifications. These were the three options that we specified when we created the simulation run in the first place. So you can go ahead and change those if you want. The next tab over is the ratio tab. And by default, there's no ratio selected. So that's what I mean by it's optional. If you never touch it, it won't change anything. However, your options for ratio method is precipitation and discharge. So if you select precipitation, then it will apply to subbasins, yes, but not sources. And then you go ahead and type in your ratio. I'll explain what that means in a moment. But if you select discharge, then you have an option, yes or no, whether it applies to subbasins and or applies to sources. Regarding precipitation, when working with a precipitation ratio, the precipitation value for each time step computed by the meteorologic model is multiplied by the specified ratio we type in right down here, say 1.25, before the precipitation is actually applied to the subbasin elements. And then if we select discharge, for instance, I'll say it applies to subbasins only, and we'll just keep the ratio at 1.25 as the example. When working with a discharge ratio, the outflow computed for each time step by the basin model is multiplied by the specified ratio right here before it is routed to the next downstream element. So this is a quick way to just change the ratio on precipitation or discharge. Okay, the last tab here is states. Again, its default it is no, so not using states. State variables are simply parameter values which may change over the course of the simulation run based on the boundary conditions and the mathematic models that govern HMS. A couple examples would be, for instance, the volume in a reservoir or the moisture content in the soil. Saving state variables have two primary purposes. The first one would be breaking large simulations into shorter time periods. And then the second one would be for real time forecasting operations. If you use save states, then the initial conditions specified in the basin and meteorologic model will be overwritten by the saved states that you use. So right now, for saved states, I have a blank and none, and it's grayed out because there's just simply no saved states in my project right now. But what I can do is say yes to saving a state, give it a name, run the simulation, and then next time I will be able to select that named simulation as one of my saved states, which will override, like I mentioned, the meteorologic model parameters or the basin model parameters that are part of the basin model and meteorologic model. Let's go ahead and do an example first. I think that would be the easiest way to understand it. So for name, I'm just going to call this. Actually, let me start by specifying the date time. And to do that, I first want to check out what the control specifications are. So I'm going to click on components and then control specifications right here. This simulation is called May 1996, but it actually starts at April 28 and goes through May 3rd. So what I'm going to do is just record the state variables at May 4th at the beginning of the day, so the very end of this simulation. And then that's what I'm going to call my state variable record. So go back to Compute tab here, click on the simulation, then click on States, and then I'm going to specify that date time that will represent the end of the simulation. Okay, so now that gives me a better idea of what should use for a name. This is just a recommendation that the name should be the date, time, and possibly some other information about these saved states. And then I'm going to say 0 hours. That looks good. The description is optional, but I'm just going to type in the same thing and then description like that, just to see what happens. And I think we're ready to go. So when I'm going to go ahead and save that, when I run the simulation, it should save a results for the simulation, of course, as well as this basin state at this particular time, specified date and time. Before I do that, I'm going to go up to my project directory here, which is right here. And I wanted to point out by default, I'm going to have nothing in my results directory. And also in my basin states, I have nothing in my basin states directory. So we're going to revisit this in just a moment. All right, who's ready to run a simulation? We can do that two different ways. We can just right click on the simulation and click compute, or up here in the compute toolbar, we can select the simulation right here and then click this exploding raindrop icon button, which is compute all elements. So let's go ahead and run that. And it ran fine, it looks like. Let's go back to that directory. And here I'm in the basin states directory. It uploaded with my basin state data. I'm going to go ahead and do a quick peek at that. Here's the basin state data. This is the index file, which just lists the different basin states. So that's not too exciting. And then here's the actual basin state file. So if I open up that, I have the same header data as well as a lot of basin state data. What the takeaway is now, if I go ahead and run another simulation, I can go ahead and select that record, and I can save a new record if I want. But now that's ready for me to select. So this is the basin states folder. But if I go up to results, I should have a record for my results as well. So this is the results data. I'm not going to open this up from Windows. I'm going to go ahead and click the results tab here and then expand the simulation runs folder. And now here are the different ways to access the results. I can access results from a simulation here in the results tab or from the basin map itself, which may be a little bit more intuitive if you want to focus on just one hydrologic element, which is also available here in the Watershed Explorer. So let's go ahead and do that briefly. I'm going to go ahead and select Junction 1, for instance, and then right click. Now, if I want to view the results for this one hydrologic elements, I'll just go ahead and click Results, and then it has the name of the simulation run right here. I can select Graph, Summary Table, or Time Series Data. So let's just check out the graph, for instance. Here we have a plot of the flow. What we have is a junction here. We're looking at junction 1, which has inflow from two different subbasins. So right here is the subbasin from Stump Creek, and then a little bit more inflow coming from E.B. Mahoning Creek subbasin. And then the sum of those two represents the total outflow from that junction. The data that populates that particular plot is shown here in the time series table. So we had three lines, the same way we have three different data sets right here over the course of the entire 6-day simulation. Lastly, we have some global summary table right here, which is just a snapshot of certain values of particular importance, like the peak flow, the volume in inches. We can change that to acre feet as well, and also time of peak discharge. All those results that we just saw can also be accessed from this results tab. For instance, if we expand the junction 1 icon right here, and then we click on the graph, this is the same graph that we just saw. Here is the time series table, and then this is the summary table. So those are those three right there. There's more results to discuss, but for this lesson, I just wanted to focus on creating a simulation run, modifying some of the properties, and then discussing some of the properties in these tabs for simulation run, ratio, and basin states.